Hello students, welcome to the next video on logic gates. Yesterday we studied about OR gate. What was OR gate? I said to you that the output is equal to A or B. That means if the inputs are high, right? If one of the inputs, either A or B is high, the output will also be high. And if both of them are high, then also it will be high. So we had a truth table A, B and Y. And I explained it to you with the help of diodes, right? How it is forward bias and reverse bias. If I have an input 0, 0, 0, 1, 1, 0, 1, 1. These are the four possibilities we have with the two inputs. First, let me draw the logic symbol, right? So this was the logic symbol, I drew it. Okay, there are two inputs are there. Okay, this is A and this is B and the output is Y. Okay, in this gate, when we said 0, 0 is applied, that is low, so the output will be low, 0. Either or. Now A is low, B is high, but one of them is low. Because of that, you'll find either or. One is low, other is high, the output will be high. One of them should be high, minimum, that is the condition. Next, 1, 0. Again, A is high, B is low, no problem, and it will conduct and you will get an output 1. Now both are high, so naturally you will find the output will be high. So you have 0, 0, 0, 0, 1, 1, 1, 0, 1, 1, 1, 1. Don't mug it up, please. Don't mug it up, right? You remember this like this. Either A or B is high, the output will be high. That's all, right? Here you see, this is high, both are high, so all these are high. Never mug it up, right? Understand the concept. Why is it called this gate? Either A or B. We do not use the word plus for it. You know, there's no plus and minus and no multiplication and all. Just it is only A or B. You have to say like that. That is called the Boolean expression. There is something known as Boolean mathematics, but I don't Boolean algebra. That you don't need it because at this level. And remember, I am shooting all this for the sake of NEET 2024 purposes. So my dear students, just to focus on the basics and try to understand the concept. Okay. Now, we shall move to the next type of gate, and that is AND gate. So the very word AND, A and B. You see, I put a dot. Okay, both A and B is high, the output will be high. This is the Boolean expression. Very simple we will do, right? Let me draw the logic gate. You see, I have drawn a straight line and I have drawn like this a T. Okay, and this is the output, and these two I am going to take as input, right? A and B is the input and Y is the output. Now we will construct the truth table. A, B and Y, right? And what are the input possibilities? Two terminals are there, right? 0, 0, 0, 1, 1, 0, 1, 1. These are the four possibilities for inputs we have. Now what should be the output? It's very simple, very logical, right? There is a relation between the input and the output, and this is the AND gate. The word is both A and B should be high. Both are low, output is low. Both A and B should be high. This is low, simple, put it 0, right? Both, again 1, this is low, simple, put Now here both, so naturally 1, 1, 1. This is the truth table of AND gate. My dear students, this is enough for you. But still, I would like to explain how we can realize it using diodes. Using diodes. But for you, this is more than enough. But still, I will tell, something basic concept. We can explain this with the help of diodes also, right? And I'll explain it to you, then you will understand better. Okay? As usual, as we did yesterday, the words which we use are very clear. Forward bias, reverse bias, right? Forward bias, current will flow through. Reverse bias, no current will flow through, right? So this is the thing. And I'm going to tell you something differently I'm going to draw. So let us see how I am drawing it, right? So I have got a terminal A and I have got another terminal B. Now I am going to connect it, you see, opposite to what we drew yesterday, and this is negative and this is positive. And again I got it and I switch here, right? Negative and positive. And again it comes out, and you can join it together like this. But yesterday I connected the output to ground with the load resistor. But here we are going to change a bit of it. Differently we are going to do it. What we do here, we connect a 5 volt plus 5 volt battery. Okay? And from plus 5 volt battery, see this point I want to come, plus 5 volt battery, I will connect a load resistor, right? RL. See, yesterday it was reverse down, but today it is opposite. I have drawn it. Now let us try to realize the logic, the truth table of this logic gate, right? A, B, Y. Okay? A, B, Y. See, I am not writing the symbols, values here. See, I apply 0, 0. Right? This is negative, it is low, and it is positive, it is high. And this is high, and this is low, as usual. See, low, low, right? That's one part of it. Now, from here, a current will flow through, and a current will come through, and a current will pass through. This is positive, this is positive. So, forward bias, this is forward bias, this side. But this is being low, this is being low. We say it is short circuited. It is short circuited, so that the value here will be simply, here it is like a blank line. We can say this is short circuited. Okay, short circuit. Okay, so no current will flow through because it is coming like this. This is a low value, so naturally it will be short circuited. Similarly, now you see plus is there. This is plus, forward bias, but again it's a very low value, and again the circuit will be short circuited. When it is short circuited, no current flows through it. When it is short, you would have heard about short circuiting of a circuit. Quickly high current will flow through and then stop the whole circuit. Like that, when it is short circuited, in this case in the diodes, you will find no current will flow through. Okay, now, so what happened? 0, 0, the output is 0. Now, we will change the condition, inputs. 0, 1, 1, 0. So, let us apply 0 here and 1 here. As I said earlier, this is come straight like this, right? It is forward bias, but what is happening? This is a low value. Okay, that is why it is short circuited. But what about this? This is high, and this is low. And that is why it is in reverse biased condition. In reverse bias condition, again there is no current flows through, the output will be 0. Again, my dear students, I would like to explain it, trying to little bit understand it. Yeah? See, here it's plus 5 is there, load resistor is there, and the plus 5 is coming, right? It's short circuited. right? Short circuit, I write here short circuited, SS, right? Short circuited means no current will flow through because the potential is going to be here, it's going to be low, this is also turned to be low, so there is no current flowing, right? And here, what is going to happen? This is high, but this is low. So naturally, this you will feel it is a reverse biased. When it is reverse biased, you can imagine to be a open circuit. Yeah, a open circuit in which no current will open circuit. It's an off state, so no current will flow through. So output is zero. I hope you understand. Yes, don't get confused. Now, I change this to be 1 and I change this to be 0. And again, this is positive and this is negative, right? And opposite, positive to negative, it is reverse bias. When it is reverse bias, it will act as a open switch. And here, it is low, we have applied here 0 and it is also low. A current comes through it and then it is low value. So naturally what will happen? It will get short circuited. When it is short circuited, naturally no current will flow through. Dear students, you can think in another way. If it is negative, right, low value, and it's a low value, what will happen? Very minute current. That means I can use the word in PN junction. We can have in reverse bias condition a very micro ampere, the very low current will be there, right? And that is really a negligible value. That's why we say it is short circuited, right? So these are the two unidirectional condition. The diode is always unidirectional, right? Only one direction it will go. Positive to positive. Again, I am drawing it for you. Positive to positive, negative to negative. This is called forward bias. Now I reverse it, right? If I make it in reverse condition, positive to negative, negative to positive, then you will find that it is reverse bias and no current will flow through. Yeah, this is the basic function of a PN junction diode, which is only unidirectional in its nature. My dear students, again I am removing all this so that you become very clear, because my purpose of using for till this, it is over. Again 1 0, we put the condition 0, last 1 1. Now let us try to understand this, right? Let me erase all the stuff neatly. Okay, now you see. Yeah. See, again terminal A, 1. 1 means high voltage, higher voltage. Maybe 1 volt, 2 volt, any value. And here it is 5 volt. Yeah, less than 5 volt. It should be, here whatever you apply should be less than 5 volt. Maybe it can be, let us say 2 volt, right? And 2 volt, it is high. This is a high and this is low and this is reverse biased, right? And this is again high and this is low and again it is reverse biased. So what will happen? Both the diodes will not conduct. When both the diodes does not conduct, what about the current coming from the positive 5 volt? That current will come to the load resistor and we connect a multimeter or a voltmeter here. It will show the value and that is a output here, and that is why 1 1 leads to 1. Now you again see, yeah, Y is equal to, output is equal to A and B. When both A and B is high, 1 1, the output will be 1. Otherwise it will be 0 in all the other cases, right? So with this we have completed the second type of gate, right? And the second gate, which is AND gate. These are the basic gates. Now one more gate is there, that is NOT gate, which I will do in the next session, next video. Before that, I would like to give you in terms of switches. Now you see, for example, I have a switch here, right? Let us keep a switch here. And let me keep another switch here. Okay? Now, I connect this here and let us connect a resistor. and let us connect it here. Okay, this is the output. This is the load resistor. This is switch A and this is switch B. Very simple, right? And I will say this is the input, right? I can give an input from here, positive, like this, okay? Positive, negative. I can connect it like this. This is 0 volt and this is 5 volt, plus 5, and this is minus. Plus and minus is there. Now I connect from here, 1 to here, 1 to here, right? Now you see what's going to happen. When both of them are 0, 0, right? When it is 0, 0, it is like the switches are being open. It is open. Then what will happen? No current will come through. So Y is equal to A plus B. That is A or B. I am explaining OR gate to you once again with another approach, right? So A, B and Y. 0, 0, 0, 1, 1, 0, 1, 1. Watch carefully. 0, 0, off, off. So 0. Now you apply 0, 1. That means the switch is on, right? This is off. Even 1 is on, also current will flow through. Okay? So naturally there is an output 1. Now next case 1, 0. Then switch A is on, switch B is off. Doesn't matter. Current will flow through 1. Now next case, both the switches are on because both are high. Again output is high. Okay? Do you understand now? This is in terms of switches. We can also draw. Remember to draw it in parallel. Right? In OR gate, remember to put it in parallel and answer that. Now same thing I can explain for AND gate also. AND gate. Either A or B. That is over. Now both A and B. Right? Okay. Sometimes you may tend to say plus and dot. It's okay. No problem. Now what is going to happen? The circuit is going to just change little differently. Right? We will connect both the switches like this. A and B. Okay, A and B. Now what about the truth table? Input possibilities are same. 0, in this it is going, right? And what will happen? Both A and B should be closed. Both A and B should be closed, then only output will be there. If one of them, A is open, no current will flow through. So the A is open, no current will flow through. Okay? Or let us say A is closed, by B is open, again current will not flow through. No problem. If both are open, very simple, no current will flow through. So output is 0, 0, 0, 1. Again, my dear students, again and again, I repeat, understand, and then you'll be able to solve this without any problem. And because in NEET examination, there is going to be one question based on gates, right? I have to shoot around 6 or 7 videos to cover all the ideas which have come in PYQs. I am trying to cover some 6 years PYQ questions for you. Maybe I will shoot some 10 videos if possible, and there's every possibility that you will be able to understand the concept and you will be able to succeed in the NEET 2024. Thank you so much. Take care.